Page 187, 188. What you got? Questions off that? And remember, this is off the normal curve. So a few things just to know with the normal curve. When they ask what percent is below, and you're using the normal curve, that is like this region. If they ask what percent is above, that would be this side. And then sometimes they might even ask you what would be between. Hey, I think very little. All right, gotcha. What percent is between? That would be, an area like, something like this. Okay, so those are just some things that you know about the normal curve. So when they ask you, hey, what percent is above or below, and you look at it and say, well, how the heck am I supposed to know that? Well, you really just have to look at the normal curve, and you have to add things up. And the quickest way really to add things up is, one, if you know that you have a normal curve, such as any of these, and I'm saying normal curve, they're calling it a bell curve. I mean, it's the same idea. If this is the mean and the median, that means 50% of the data is over here, 50% of the data is over here. That's the first thing to know. But then we can break it down into subsections. So if I was going here or here, I'll use the red. But then we go to a standard deviation between the two, and I need to flip back because I always got to make sure my numbers are right. 34% here, 34% here. So one standard deviation from the mean is 68%. Then I have 13.5%, and I have 13.5%. It's symmetric. And then this one's 2.35%. And then this one is a measly little 0.15%. So it's a matter of you just being able to add those values. Now, we'll give you the normal curve. Yes, you're more than welcome to put the normal curve on your note card as well, but we'll make sure you have it. If we don't have it on the test, I'll make sure it's up on the board so you can look at it and broken into those categories. So when they give you this information, the one thing on the homework that did specify, so one was number 6. And it said this person was taller than 84% of the U.S. population. How tall was he? So they told you in the original, they said, hey, this was a 69-inch person, and then you went up by 2.5, added 5 here to the original, added 7.5, subtract 2.5, subtract 5, and these are percents, subtract 7.5, okay? And I'm not doing the math for it, I'm just saying that. So if you wanted to figure out where that 84% really lives, it lives, think about it, you have 50% this way. If I add 34 to 50%, you get to 84%. So if I add those two together, okay? So that means that this person in this problem is 2.5 inches above the average. Well, if I take the 69 plus 2.5, I'm going to get 0.5. What is that? 1, carry 1, 71.5 inches tall. Excuse me. Does that make sense how you look at that? So again, you have to know that when they're giving you this, we're not giving you an arbitrary value. A z-score we will be working with later in this chapter. We talked about a z-score originally, but then the z-score itself, might find, hey, and we're going to use a calculator, so it's called a normal CDF that we'll use, and it'll find you what the area is to the right. If I wanted to take this same question, so if he's 71.5 inches tall, he's at the 84th percent, or he's 84% at the 80. He's taller than 84% of the people in America, or whatever the worldwide, or whatever it is. That means 16% are taller than him. So the 16% is this region over here. How tall are those people? taller than 71.5. Do we know exactly, how tall they are? Not at this point. But if you're saying, hey, it's a normal curve, you need to refer back to the normal distribution. And then on our second page, it talked about the data. Did somebody get the answers for 11 through 15? Or what did you get as far as the mean, the standard deviation, and Q2, which is the median? Did anyone get that? I don't have it written down, and my calculator's not working on my things.
For the mean, I got 13.99.
13.99 was the mean. Okay. Standard deviation?
I said 4.99.
4.99. Got that. All right. And then what was the median?
That's a good question. I don't think it asked. Yeah, it doesn't ask for the median.
Oh, I think we needed to judge if it was good on the distribution. So is it still on your calculator by chance? Anyone still have that data in their calculator? If not, I'll plug it into. You got it there? Edit step.
Oh my god.
Can I borrow that? Plug it in real quick. All right, so I have 17.2, 16, 16.3, 14.9, 2.5. Wow, that's 19.3, 7.6, 11.2, 28.4, 15.3, 17.2, 9, 15.2, 15.9, 11.6, 12.5, 15.2, 8.5, 16.3, 17. What did I do? What happened? What did I do wrong?
I was confirming the calculator. For standard deviation on the calculator, it's SX.
It's always going to be the one that brings up the smaller or the bigger number, unless you refer to the entire population as a whole.
Okay, so you want sample.
Yes. Yeah. So calculate one variable stats. List one. Calculate. Let's just verify we have. All right. 13.99. I agree. SX. Yeah, let's change this to 5.10 because that's the SX standard deviation because we have the sample. And then Q2, whoa, dang it. Stat, calculate, one variable stats. Q median is 15.05. Okay, so now I have enough information for this. Thank you for allowing me to know that. Okay, so think about what this normal curve would look like. Okay, right here is 13.99 as the mean. Agree? The standard deviation would be 1 over, so we'd add plus 510 to get here. But then they say, hey, we have 15.05. So 15.05 is our median. Okay? So if we left our normal curve graphed like that, that's basically what we're looking at. For it to be a normal distribution, the normal curve should have a median and a standard deviation, or excuse me, a median and a mean exactly the same. It's not. It's off by 1.06. Okay, and 1.06 doesn't sound like a lot until you're dealing with your figures. So what this normal curve would actually look like, it would look something like this. Okay, so the mean is going to pull it left. Okay, meaning it's going to take it's going to have this long tail. So then this becomes skew right, and skew right isn't a normal distribution. You have something that's pulling it out there. Then you could evaluate, and it's not asking you to, but you could evaluate outliers that might lay there. So use a calculator to find the mean and standard deviation. Did it. What percent lie between one standard deviation from the mean? Well, as far as the normal curve goes, it should be 68%. what lie between two standard deviations, the mean? It should be 95%. What percent of the data lie between three standard deviations? That's the 99.7 or whatever it is. And then from the information above, do you judge this data represents normal distribution? It is not normal distribution because our median is not the same as our mean. Okay, so you had to do all that just to show answer 15. Okay, so again, a normal distribution, it's always nice when someone says, hey, we have a normal, if someone's telling you you have information and it forms a normal distribution, that means the mean needs to be equal to Q2, which is the median. Okay? That's the most important thing. But then also when you evaluate your situation, if these are the same, for the most part, as far as right now, that's going to justify to us, do we have a normal distribution? Now, if you have data that's plugged in and it's in the hundreds and even the thousands of numbers, like if you are plugging in how many houses are in medium to large cities across America, your mean and your median might be off by a little tiny bit, but then it becomes a judgment point. So like if we said, hey, we had a mean here that was 1,000, and then we had a median, so we'll call it Q2, of 1,002, and let's say we have 200 million pieces of data, yeah, that's pretty normal distributed, okay? These numbers are not that far off. It's when this number gets really obscure, becomes a larger percent away, is what we have to look for, okay? So that's 3-1 to 3-3. Are there any other questions off 3-1 to, or excuse me, just 3-3? I apologize. All right, and I haven't written this on the board yet because I had class this morning. I would like us to take the opportunity to work on the review 3-1 to 3-3. We will have a quiz tomorrow on this. So if you need note cards and stuff, that's fine, but we are going to work on page 189 and 190. Happy to answer any questions about them, but you have the rest of the period to work on that, okay? If you don't have your book with you, take a picture of your friends, do it on your own. Don't just sit there looking at your phone. Quit being like my freshman.